paper is about a computational model of cognitive biases in commercial banking decision-making process. There's a couple of reasons why this research is important because the current situation that banks using machine learning and AI algorithms, they are based on bias-free assumptions. But it's not always true because officers usually show their bias during decision making, such as group thinking, risk aversion. So this research provides a tool to quantify cognitive biases and show how many impact they have on those decisions. There's a couple of references that show the importance, such as in 2008, behavioral biases, they contribute to systematic risk in global risk financial crisis. And some loan officers show risk aversion and they are impacted by the previous experience during decision making. There's also some linkages to the cognitive science, such as this paper will turn the mental abstract into the more measurable variables, and we also try to quantify the calculation process of mental computation, and also recommending human AI hybrid model and human computer interaction as one of the solutions for the current challenges. In terms of the design, this paper follow a framework to examine the research question. First, we identify the biases, and then we make up the assumption in data collection and the model we selected, and finally we follow a validation process to ensure that we have the expected results. In terms of the input and output, we collect both traditional and the biases that's coming from the mental abstracts, such as the products, time, location. They are traditional variables without bias. However, like risk aversion, escape index, and also the easiness to bypass information, those are the variables try to measure the impact of the cognitive bias. And for the output, we're learning about the application approval ratio. For the model design, we first designed the baseline model. This is the one that aligns with the current practices that commercial bank is using, and we will use regression model. And for cognitive bias model, we first design the bias indicators, and we will recommend to select a couple of models and compare the output, including random forest, SG boosting, and neural networks. In terms of the result, first of all, we have a couple of key benefits. First of all, it introduces a measurable way to measure cognitive factors in the banking models, and we enhance the predictability of the credit and risk decision. And by including all these variables, we improve fairness and transparency, and also we strengthen the training design that helps the bank to recognize how these biases could impact the business. From application perspective, first of all, this research can be used in HR and training process, that they can identify the high pressure roles and tailor the training. And also this could generate a bias augmented model that improve the consistency between human judgment and AI scores. And also regulators can use this framework to audit decision making and to promote responsible AI. This paper will help bridge cognitive science and financial decision making through computational modeling. It will quantify the cognitive biases into measurable indicators, and also demonstrate how mental biases can alter banking decisions. Other than that, it brings out the managerial implication and also provide a good foundation